Hello, in this video we will compare the voltage of light bulbs connected in series. So I'll start with a battery. I'm just going to turn it around so the positive side faces on that side, and some wire and one light bulb. And we're going to measure the voltage over the light bulb and over the battery. So if I select the voltmeter, and keeping in mind that that is the negative end of the battery, so that is the negative end of the light bulb, that is the positive end of the battery, so that's the positive end of the light bulb. So I connect the red lead, which is positive, to the positive end, and the black lead to the negative end. So the voltage across the light bulb is 9 volts, and the voltage across the battery is also 9 volts. Now, if I built a very similar circuit, this time having 2 light bulbs in series instead of 1, the first thing I'm going to notice is that these 2 light bulbs are not as bright as the 1 light bulb. Now, this will make sense when we start reading the voltage over the light bulbs. So if I read the voltage over the first light bulb, I will see that it's 4.5 volts. And the voltage over the second light bulb is also 4.5 volts. If I compare this to the voltage over the battery, I will discover that the voltage over the battery is 9 volts. So 4.5 plus 4.5 is 9, which means that the 2 light bulbs split the 9 volt voltage between them. So light bulbs in series divides up the voltage. Here you can see that the 9 volts is divided into 4.5 volts and 4.5 volts. So the next thing I'm going to do, I'm going to build a circuit with 3 light bulbs in series. Already, if we look at the 3 light bulbs in series, they're not as bright as the 2 light bulbs in series or the 1 light bulb in series. The voltage of the battery hasn't changed because it will still be 9 volts. But if I compare the voltage over each light bulb, this has changed because now the first light bulb is 3 volts, the second light bulb is 3 volts, and the third light bulb is also 3 volts. So what has happened? The 3 light bulbs in series has divided up the 9 volts of voltage that was created by the battery equally amongst the 3. If the light bulbs are identical, then 9 volts will be divided up equally so that each light bulb has 3 volts. But if they were not identical light bulbs, this would not be the case. However, the voltage of the 3 light bulbs, no matter what they are, when added together, they would still come to a total of 9 volts. So the voltage of the battery is divided between the 3 light bulbs in series. This might not be the case when the light bulbs are in parallel, but it certainly holds true when they are in series. Thank you. Hello everyone. I'm going to show you an experiment now which compares light bulbs in parallel, specifically looking at the voltage. But before we look at... Hello everyone. So today I'm going to show you how to calculate total resistance of resistors in series and in parallel. So what I've got on the screen here, I've got a circuit showing 2 resistors in series. The circuit has a resistor of 2 ohms and a resistor of 3 ohms. Now when resistors are in series and we need to calculate the total resistance, we use the formula RT is R1 plus R2. We simply add the resistances up. Where RT is total resistance, that's the resistance of resistor 1 and the resistance of resistor 2. So resistor 1 has got a a resistance of 2 ohms and resistor 2 has a resistance of 3 ohms. So the total resistance would then be 5 ohms. Now if the resistors were in parallel, it's a different calculation. So here's the same circuit, except with the same amount of voltage and current, but except that the resistors are in parallel. So when they're in parallel, we calculate it as follows. So we will write the formula as 1 over R total is 1 over R1 plus 1 over R2. And so 1 over R total will equal 1 over R1, which is 2, plus 1 over R2, which is 3. And then we have to find the lowest common denominator, or write these as fractions having the same denominator. So 1 over 2 would then be 3 over 6. And 1 over 3 would be 2 over 6. And so 1 over R total will be 5 over 6. So to find R total, we have to say R total over 1. So we're swapping this fraction around, putting what is in the denominator into the numerator and what is in the numerator into the denominator. We've just swapped it around, and we also swapped the answer around. So R total over 1 is 6 over 5. Now we can leave the over 1 part out and just write R total, which will give us 6 over 5. And that will be ohms. So you can see the total resistance is much lower when two resistors are in series than when they are in parallel. Now if you were also asked to calculate the total voltage, if we look at the parallel circuit, if I had to calculate the total voltage, I would use Ohm's law. So Ohm's law, which is resistance is voltage over current, I would write it in a different way. I would write voltage is current times resistance. So this is the formula I will use to calculate the voltage. So the current is 2 amps, and the total resistance, we have just calculated it to be 5 ohms, which will give us a total of 10 volts. Now in the case of the parallel circuit, we do exactly the same. Since the current is 2 amps, so once again, we'll write Ohm's law, which is R equals V over I. We'll write that as V equals I times R by changing the subject of the formula. Then we will put 2 amps for the current, which is I, and the total resistance would be 6 over 5 ohms. We'll multiply that by 6 over 5 ohms. And so the voltage will be 12 over 5 volts. So 12 divided by 5 is 2,4, and that will give us a total of 2,4 volts. So there is a difference between the circuit where the resistors are connected up in parallel has got quite a low voltage, but the circuit where the resistors are connected up in series has a much higher voltage. When the resistors are in series, they have a high resistance. When the resistors are in parallel, they have a low resistance. Thank you. I hope you found that useful.